Welcome to Astronomy in the Renaissance. Nicholas Copernicus, 1473 to 1543. Nicholas Copernicus could not reconcile centuries of data with Ptolemy's geocentric model. Consequently, Copernicus reconsidered Aristarchus's heliocentric model, with the sun at the center of the solar system. Heliocentric models explain retrograde motion as a natural consequence of two planets, one being the Earth, passing each other. Copernicus could also derive the relative distances of the planets from the sun. Copernicus, however, had problems and could not predict planet positions any more accurately than the model of Ptolemy. He could not explain lack of parallax motion of stars, and it conflicted with the Aristotelian common sense. Tycho Brahe, 1546 to 1601. He designed and built instruments of far greater accuracy than any yet devised. He made meticulous measurements of the planet. Tycho Brahe made observations, supernova and comet, that suggested that the heavens were both changeable and more complex than previously believed. Tycho Brahe proposed a compromised geocentric model, as he observed no parallax motion. Johannes Kepler, 1571 to 1630. Upon Tycho's death, his data passed to Kepler, his young assistant. Using the very precise Mars data, Kepler showed the orbit to be an ellipse. Using Tycho Brahe's data, Kepler discovered that planets do not move in circles around the sun. Rather, they follow ellipses, with the sun located at one of the two foci. Astronomers use the term eccentricity to describe how round or stretched out an ellipse is. The higher, closer to one. The eccentricity, the flatter the ellipse. Kepler's first law. Planets move in elliptical orbits with the sun at one focus of the ellipse. Take notice of the diagram to your right. Kepler's second law. The orbital speed of a planet varies so that a line joining the sun and the planet will sweep out equal areas in equal time intervals. The closer a planet is to the sun, the faster it moves. Kepler's third law. The amount of time a planet takes to orbit the sun is related to its orbit size. The square of the period p is proportional to the cube of the semi-major axis A. Kepler's third law. This law implies that a planet with a larger average distance from the sun, which is the semi-major axis distance, will take longer to circle the sun. Third law hints at the nature of the force holding the planets in orbit. Kepler's third law can be used to determine the semi-major axis A if the period P is known, a measurement that is not difficult to make. Thank you for your time. See you tomorrow. Bye now.